Dispersion of light is a phenomenon where white light, which appears colorless to the human eye, is separated into its constituent colors when it passes through a transparent medium like a prism. This phenomenon occurs due to the different wavelengths of light being bent by different amounts as they enter and exit the prism, which causes them to spread out and form a spectrum of colors. Here's a step-by-step explanation of how dispersion of light occurs using a prism. White light source. White light is a mixture of all the visible colors of light, including red, orange, yellow, green, blue, indigo, and violet. Each color corresponds to a different wavelength, with red having the longest wavelength and violet having the shortest. Prism. A prism is a transparent optical element with two flat, polished surfaces, faces, that are not parallel. These faces are typically triangular in shape. When white light enters a prism, it slows down and bends due to a change in its speed as it moves from air, a less dense medium, into the denser medium of the prism. Refraction. As white light enters the prism, it undergoes refraction, which means that the different colors, each with a slightly different wavelength, are bent by different amounts. This bending of light occurs because the speed of light is different in the prism for each color due to their varying wavelengths. According to Snell's law, the angle at which light is bent, the angle of deviation, depends on the refractive index of the material and the angle of incidence. Dispersion. Since each color of light bends by a different angle, they separate from each other within the prism. The shorter wavelengths, blue and violet, are bent more than the longer wavelengths, red and orange. This separation results in a spectrum of colors, with red being the least bent and violet being the most bent. The other colors, such as orange, yellow, green, and indigo, fall between them. Emerging from the prism, after undergoing dispersion inside the prism, the separated colors continue to bend again when they exit the prism and enter the air on the other side. However, they exit at slightly different angles, maintaining their separation. Observing the spectrum. When you look at the light emerging from the prism, you see a beautiful spectrum of colors fanning out from one side of the prism to the other.